In this video, we'll find out the acceleration due to gravity of on the moon surface, and the given parameter, the given value is the density of the moon. The radius of the moon is also given, the density and the radius is given. From these two information, we're going to find out what is the value of acceleration due to gravity on the earth, on the moon surface here. So we know that the acceleration due to gravity is given by this formula here, gm over r square, where m is the mass and r is the radius. So we need to first find out what is the mass of the moon. As the density is given, we can find out the mass from this equation. The density, the rho is this density here, and V is the volume. So the density is a mass per unit volume. So we're going to solve for the mass is equal to density times volume. The volume, this moon is a sphere, and the volume of a sphere is given by 4 over 3 pi r cube. That's the volume of a sphere. So the density as it is and the volume in terms of radius is now this much. So let's plug in all the values now. The density is given here 3340, and 4 over 3 is constant, pi is constant, and the radius is given here 2. So just plug in all the values now. So once you plug in all the values, we found out this is the mass of the moon. That's the mass of moon. So the acceleration due to gravity on moon surface is given by this formula here, g m over r square, where m is the mass of the moon and r is the radius. We know the mass of the moon here. G is a universal gravitational constant. So this value is 6.67 times 10 to the negative value, negative 11. That's the value of universal gravitational constant. R is the radius, which is already given here, 1.7 times 10 to the 6. So once we plug in all the values, what you get is 1.59 meter per second squared. That's the acceleration due to gravity on the moon surface here. So now let's compare this value with the acceleration due to gravity on the Earth's surface. So we know on the Earth's surface, the value is 9.81 meter per second squared. So if we compare these two values, g moon over g earth, what you get is on the moon surface, acceleration due to gravity is about 1/6 time smaller. So the ratio of the acceleration due to gravity on the moon to the Earth's surface is 1/6, about 1/6. This also means that if you weigh 660 Newton, let's say for example, on the Earth's surface, then your weight on the moon surface would be 100 Newton, because the g value is 6 times smaller. Okay, so, or if you weight 100 Newton onto the Earth's surface, or let's say you weight 400 pound, let's say for example, 400 pound onto the Earth's surface, then your weight onto the moon would be 400 divided by 6.16. Whatever the number comes out, that will be your weight onto the moon surface. Remember, what we measure is the weight, not the mass. The mass, whatever you measure the mass will be a constant quantity. Mass does not change. What we measure is the weight. So the weight will change, not the mass. Okay, so this is it from this video. Please do not forget to like, share, and subscribe the channel. Thank you very much.